Today we're working on compositions of isometries. This is section 9.4. We've talked about isometries already. We said it's a transformation that preserves the distance. Rigid motion preserves distance and the angle measure, but isometry just preserves distance or the length. So translations, reflections, and rotations are all isometries because all of them are going to preserve the distance. So in your composition notebooks, let's put theorem 9.1. This one says that the composition of two or more isometries is an isometry. So if you do a translation, then a reflection, and those are both isometries, the new figure that you get would also be an isometry, and that makes sense. Theorem 9.2, this is reflections across parallel lines. This one says a composition of reflections across two parallel lines is a translation. So basically, when we see parallel lines, we think, okay, two parallel lines cut by transversal, alternate interior angles, same side supplementary angles, alternate exterior angles, corresponding angles. And now, if we have parallel lines and we have reflections across two of them, we know that two reflections is going to give us a translation. So to write this as a composition, it's going to be reflection over, in my case, I use line M and line L, and these two lines are parallel to each other, and that's going to give me my image, which is A prime, B prime, C prime. So you reflect, in this case, a triangle over line M, and then over line L, and these two lines are parallel, and you're going to get your final triangle, which is going to be just like you translated it. Another way to write this composition, and I don't usually write it this way, I usually do this one to show composition, but you can say capital R, and then your line M, and then your capital R, and your little cursive L. So those are going to be your reflections. For triangle ABC is going to give us the image triangle A prime, B prime, C prime. The next theorem in your composition notebook is reflections across intersecting lines. So if they're parallel and you reflect across them, you get a translation. If they're intersecting lines, which means you just cross each other, make an X, then a composition of reflections across two intersecting lines is a rotation. This one gave you a translation. This one gives you a rotation. Now, when we have intersecting lines, what do we know about the angles formed by intersecting lines? Yep, we get vertical angles, and vertical angles are congruent. Okay, continuing. Any composition of isometries can be represented by either a reflection, translation, rotation, or a glide reflection. Okay? All right, so let's look at what is a glide reflection. A glide reflection is the composition of a translation, which is considered a glide. You're just moving from one location and gliding over to another location. And a reflection across a line parallel to the direction of a translation. Okay, lots of words there. Let's see what they're talking about by doing an example. All right, so here is an example. And it's really easy. Once you practice a little bit, it's going to make sense. But if it doesn't, you can send me a message on Remind or a message on Google Classroom, and I'll try to give you another example or explain this one again. So if I want you to find a glide reflection image, so let's say I have the reflection over x equals 0, which is what? The line at x equals 0. We've talked about horizontal and vertical lines. This one's going to give me the vertical line, which is the y-axis, okay? And a translation with the vector 0, -5. So it's going to move down on the y-axis. So my pre-image is triangle TEX. So here's my pre-image, okay? So we start with what is closest, and we are going to translate down 5 for each of the points. So E is going to move down 1, 2, 3, 4, 5. X will move down 1, 2, 3, 4, 5. And T will move down 1, 2, 3, 4, 5. Okay, this is like our in-between triangle. So I'm going to take this triangle and I'm going to reflect it over the y-axis. So that means that if this point is 1 away from the y-axis, then this point would have to be 1 away. If this one is 2, this one is 2. If this one is 1, 2, 3, 4, 5, then this one has to be 1, 2, 3, 4, 5. And I will draw my new triangle, which will be the image, and that will be T prime, E prime, X prime. And that's the glide reflection image that started with TEX and took us to T prime, E prime, X prime. Okay? Try your homework problems. If you have questions, just let me know, and I'll see you tomorrow.